Our first tutorial regarding antenna simulation and modeling using Feko software. We'll be defining the variables first. Today we'll be doing half wavelength dipole antenna. So let us define the variables. Lambda 4 meters. Create. The variable is created as you see here. Then I need to create height, which will be lambda by 2, and the antenna will be from minus h by 2 to plus h by 2. So let us create height h, which is lambda by 2. We now need to create frequency, which is obviously c naught by lambda. So f is c0, which is predefined by lambda. Create it. Now we'll create a dipole antenna, which is a simple wire. So we'll create a line. Here's the line. The starting point will be minus h by 2 and the end point will be plus h by 2. I label it as dipole and I create it. So as you can see here, this is the line which is created. Now we click on edges on the sidebar and we'll add a port to this wire port. We'll add the wire port in middle. So the wire port is created. Now we will add voltage excitation using voltage source. Created. Now the voltage excitation is given. We'll set the frequency on which antenna will work, which is approximately 75 megahertz. This would be a single frequency on which our half wavelength dipole antenna would work. So we have set the frequency for dipole antenna. Now we'll request far field calculations, which are here. For a 3D pattern, we can directly click on 3D pattern and it would generate a 3D pattern of the far fields, and then we would click on generate. So the far fields are generated. Now we need to provide meshing information, so we'll create a mesh. The wire segment length which I would be taking is lambda by 20, and the wire segment radius which I would be taking is lambda by 1000, which is 2 mm. Okay, lambda by 1000. So our model has been meshed. Now we can run the simulation using Feko. Yes, we'll save this model and name it as dipole, and I save it. Okay, now since our antenna has been modeled, we'll view its simulation on post Feko. The antenna is now transferred to post Feko. So this is our dipole antenna. We'll run the simulation again here using Feko and click on OK. Now we can view the far fields. You see there is an omnipresent field, donut shaped, on an in and dipole antenna. We can view other parameters like gain from here. See, the gain is 1.64 linear, and in dB scale, if you want to see, it is 2.17 in dB scale. There are several other features which we can see, like add a graph. We can view the source data. This is impedance, admittance, voltage and all. Add a 2D graph for far fields. So this is our far field pattern in 2 dimensions. We'll request a 3D view again. We can view the far field points from here, requested far fields in line, in surface, etc. We'll be covering more of the antennas in the tutorials to come, so please subscribe to our channel and keep liking. Thank you.